This is the troubleshooting interface for PVX, looking at east-west traffic and looking at just the north-south traffic and showing some of those pitfalls there may be if you're just looking at north-south traffic. What we're looking at here is the business critical application. You can see here we've got Oracle DBM, we've got this ERP front end, ERP back end, and just kind of as it sounds, we've split this ERP application off into multi-tiers, primarily for very quick triage, very quick analysis. If we look at specifically the ERP front end, and again, this application is a three-tiered app. It's a client to a web server to a back-end database server. We're looking at this traffic in real time, but we're also keeping and retaining back in time. For example, if a problem happened last Monday at 11 o'clock, I can tell PVX, show me everything that was going on last Monday for this application from 10:55 to 11:15. It'll show us that traffic. Likewise, I can come in and look at the real time and say, show me what's going on in the last hour, last 15 minutes. What this does is it's plotting out that end user's experience. You can see we're changing from green to orange to red. Every 1 minute interval, we're recording that specific time period. This 1 minute interval from 9:05 this morning, we can see a bunch of statistics specifically breaking down the components of the delay. The EURT stands for end user response time. We can see it was 7.6 seconds. And then we've got the different components of delay underneath of that end user response time. So we've got the round trip time, both from the client and server's perspective. We have the SRT, which stands for server response time. Then we have the DTT, which is essentially the data transfer time. I can come into this specific period here, whether I was alerted to this or I was following up on a help desk ticket that came in, I can see right away where the bottleneck is. We have a 7.6 second end user response time. 7.2 of that happens to be the server delay. So how we're calculating that again is we see the request go into that first tier, we see the reply go back out. That delta is going to tell us what that server time was. From here, I can drill into this and say, hey, show me the totality of all the end users. What this is graphing out here is every single user that's running this application, 100% of the traffic, we're watching everything. And one of the things that you can see here is that around that 9:05, we had an average response time of a little over 6.5 seconds. It's color-coded based on what comprised that. I can see at 9:05 when I had my end user problems, the network was only responsible for around 500 milliseconds. Down below here, it's going to show us the servers that were involved in this, and more importantly, over here, the zones or the remote sites that were experiencing the worst performance problem. You can see right away the users in Lil are having an average of 10.5 seconds, and if I simply click on this, it's going to drill me in just to those users in Lil and show us what those response times were. As PVX builds this filter for us, we can see that actually users in Lil were having close to 50-second response times, blue indicating that this was server related. Now, as I scroll down further here, I can see the breakdown of response time by client and see that this user had an average response time of 17 seconds and 16.1 of those was due to the server delay. We drill in deeper to actually see what that end user experience was. We've got a number of HTTP calls, and what PVX is going to do is it's going to show us every single call that that user made to this ERP front-end application. I can sort this by page load time. I can see here that for this specific URL, it took 52.2 seconds. And if I drill in, we can see here that, again, that this is server delay. Back to the visibility of the east-west traffic, what we're looking at right now is just that north-south traffic. We're seeing that this GET goes out to this web tier for this specific URL, and essentially that server has a 52.2 second delay. If I were only looking at this north-south traffic, I may be led down the path of saying, I solved your problem, you have a slow web server. In the case of only having that amount of data available, that's really all we have to go on. But with PVX, it is so easy and intuitive to actually get that east-west traffic. I can go in and ask PVX to show us what's going on that back end, what's going on the east-west traffic. And now what we see is I'm looking at the ERP back end. I can sort this based on slowest query. We can see that we've got a number of calls here. Specifically, this one's taking 28 seconds for this specific SQL query to complete, really filling in that back-end visibility and being able to come in and actually look at the entire query. And you can see this one here is pretty complex. Execute, stored procedure call, select statement with all of those different conditions conditionals, the ands, the froms, the inner joins, the outer joins, the wheres, which is a lot of overhead. What I would do next is to actually hand this off to the DBA or the developer and say, why is this query so complex? That gives us what's actually happening on the back end. And PVX can do this for 20-tiered applications. This type of visibility is available. Being able to quickly deploy those OVAs in that east-west environment and begin capturing literally within 30 seconds and start learning and understanding the end-user experience all the way through that application chain from front end to back end.